lead actress moving too much?
Yes.
The cameraman's having trouble tracking. She just keeps adjusting that phone as I move.
Well, Kendra's trying to get all your perfect angles. She's like,
yeah, doing the, I can't stay still. I have to preach the gospel of physiology, so I'm having pace.
Keeps it interesting.
Camera they have where you just put a armband on and it tracks.
Oh, okay. All right, so now we're going to look at facilitated diffusion. It's still diffusion from high to low, but it can't cross the plasma membrane. It needs help. That's what the word facilitate means, by the way. It's just a standard English word that means to ease, to help. The facilities, I need to use the facilities, please. Well, the facilities help the customer because you're not going to shop as much with full bladder. So to facilitate is to help somebody do something. So facilitated diffusion is just to help get these polar things across the membrane. We had this. All right, how all of these affect how quickly diffusion occurs. Well, I'm going to move that down because I can't see that. Whoop. There we go. All of these affect how quickly diffusion occurs, except for what? Oh Lord, I gotta talk faster. Gotta get through osmosis. And I need a prop. Keep working.
Whenever she was talking about that right there, do you have a video of where she was talking about that right there, like the gas and steroids and all that? I'm gonna have to have that.
Okay, which of
because
these does not affect the speed of diffusion? Okay, someone just answered that out loud. So number 2, I'm just going to go on. See, whether or not carbon's there doesn't affect how fast it moves. All right, so facilitated diffusion is going to require proteins. And there is a distinction between a channel and a carrier. Now remember, these are passive. They do not require ATP. A channel is a pore that's always open. So stuff moves from high to low because the pore is open. It can cross through the protein. Carriers are specific to what they're going to carry. So if you look at this little diagram, I got this from your book, these little green hexagon things, when it binds to the protein carrier changes shape and it opens it. And it goes onto the inside, because remember that's a characteristic of proteins. They change shape when they bind to stuff. So it binds to the protein changes shape, the green thing now moves in, the protein changes its original shape so that it's closed at the bottom and open at the top so it can bring some more of these green hexagons across. Carriers still do not require energy though. They're just proteins changing shape because the little thing fit right in. So specificity, those proteins are just like enzymes. Remember, enzymes are proteins, so the protein carriers are just like enzymes, just like proteins. They're specific to what they can bind to. So, for example, the glucose transporters, they bind to glucose. They also bind to other hexoses, or maybe a fructose, which is a 5-carbon. However, they can compete. Transporter may move many of the same family members, but it does pick favorites. There's things that it would more quickly bind to. And then there are some molecules that can inhibit transport. So for example, glucose is moved quickly, glucose transport rate, glucose concentration. The higher the concentration of glucose, the faster it moves across the membrane. But if we add galactose to it, it slows down the process because the transporter liked glucose better. Galactose was getting in the way. Gout. Gout is a condition, can be genetic, can be from a variety of conditions, where there's too much uric acid in the blood, and uric acid crystallizes. Uric acid is crystal. Urea stays liquid. Uric acid is quick to crystallize. And when it crystallizes in the joint, it causes a type of arthritis. It's called gouty arthritis. For some reason, we mostly see it in the joint of the big toe, but it can occur anywhere that someone they have a lot of gout. All right, the treatment is a drug called probenazid treatment. It just helps the symptoms. Probenazid binds to the uric acid transporter so that when uric acid is dumped into the kidney, it cannot be pulled back. Probenazid kind of stops the door from being two-way. It doesn't allow uric acid to be reabsorbed. So uric acid winds up in the urine instead, where it's peed out. And there was a commercial a few years ago where there was a guy walking around with a gigantic Erlenmeyer flask of green liquid that was the uric acid, and he had gout, so it was like huge. And then he took this drug, and then it became manageable, and then he could carry around his uric acid load. And if you,
Wow.
So if you listen to the narrator, though, it will increase the risk of uric acid kidney stones because it's putting so much extra uric acid into the kidney. You've got to be drinking a lot of water to keep it flushed.